NASA's Curiosity rover captured this panorama using its Mastcam instrument on September 26, 2025, revealing new details of web-like boxwork ridges on Mount Sharp, including narrow, mineralized ridges and sandy hollows between them. The intricate formations are part of a boxwork region, networks of low ridges roughly 3 to 6 feet, 1 to 2 meters, tall with sandy hollows between them, that Curiosity has been exploring for months on the slopes of Mount Sharp inside Gale Crater. The rover captured panoramic images of the area with its Mastcam on September 26, 2025, providing scientists with an unprecedented look at the planet's unusual terrain, according to a statement from NASA's Jet Propulsion Laboratory, JPL. From orbit, the intersecting ridges resemble a massive spiderweb sprawled across the Martian surface. Scientists believe the ridges formed when ancient groundwater circulated through fractures in the rock, depositing minerals that hardened certain zones. Over billions of years, wind erosion wore away the weaker surrounding material, leaving behind the lattice of tougher ridges. Understanding these formations could help researchers refine timelines for when liquid water may have existed near the Martian surface, a key factor in assessing Mars' past habitability. The web-like formations suggest groundwater was present later in Mars' history than previously thought, raising new questions about how long the planet may have supported conditions favorable to microbial life, according to the statement. Until Curiosity reached the region, scientists couldn't confirm what these spiderweb-like formations actually looked like up close, or fully understand how they formed, something only a rover on the ground could resolve. But getting that view wasn't easy. Drivers had to carefully steer the nearly 1-ton rover along narrow ridgelines barely wider than the vehicle itself to gather the necessary images. It almost feels like a highway we can drive on. But then we have to go down into the hollows, where you need to be mindful of Curiosity's wheels slipping or having trouble turning in the sand. Ashley Stroop, Operations Systems Engineer at JPL, said in the statement. There's always a solution. It just takes trying different paths. Closer inspection revealed bumpy, pea-sized mineral nodules embedded in the ridges and hollow floors, another signature of past groundwater activity. Unexpectedly, these nodules were not concentrated near central fractures as predicted, but scattered along ridge walls and depressions, offering new insight on how water and minerals interacted across the Martian terrain. Each layer of the 3-mile-tall, 5-kilometer-tall Mount Sharp records a distinct chapter of Mars' changing ancient climate. As Curiosity climbs, the terrain shows a clear shift toward increasingly dry conditions, broken up by occasional wetter intervals when rivers and lakes briefly resurfaced. Seeing boxwork this far up the mountain suggests the groundwater table had to be pretty high, Tina Seeger, a mission scientist from Rice University, said in the statement. And that means the water needed for sustaining life could have lasted much longer than we thought, looking from orbit. Curiosity has also been using its drill to collect rock samples from the boxwork region. Analyses of these samples have identified clay minerals atop ridgetops and carbonate deposits in the hollows, chemical clues that shed light on the environmental conditions when these rocks formed. Using a technique called wet chemistry, a process that uses chemical reagents to help detect organic molecules, scientists looked for signatures of carbon-based compounds linked to life in pulverized rocks collected during Curiosity's recent 4th sampling mission. The rover is expected to leave the boxwork formations behind in March as it continues its ascent of Mount Sharp. Exploring this region helps scientists better understand how the red planet evolved from a wet world to the cold, dry desert seen today.